One.
AI-powered supply chain management, enhanced efficiency and optimization by Grace Dolan and Justin Carasillo. So this slide is the identification of the stakeholders. These are the shareholders that are relevant to our company, including the CEO, the CFO, supply chain managers, the HR team, clients, including businesses and partners, AI development partners, and the general counsel.
For our external interview, we spoke with Tristan Kolos, who is a supply chain manager at H2 Ocean, which is actually a local business founded and headquartered in Stuart. We asked him a couple questions. The first one was trying to pick at his current system, what they're working with. We asked, what are the main challenges you face with the current system? To which he replied, the main challenge I face with our current supply chain system is accurately determining the order quantities based on our sales predictions, especially when it comes to new product launches. With newer products, you obviously lack historical data to help you. Other questions we asked him, all which will be included in the doc with the transcript of his answer, was are there specific features or tools you wish were available in the current system to make your work easier? Which he said it would be easier if the system was directly connected to our physical inventory to prevent any discrepancies between recorded and actual stock levels. Maybe a feature that incorporates barcode scanning technology for tracking each item as they enter or leave the warehouse would be ideal. And lastly, the one that we'll go over is how would the integration of AI in your supply chain management system help you? To which he answered, if we were to integrate AI into our supply chain management system, it would completely transform the way we manage inventory. The accuracy of demand forecasting, analyzing sales data, and external factors like trends or seasonality, we would be able to plan inventory more effectively, reducing overstock and stockouts, and optimize our order quantities. So, just with that, we could already see a real world example of how AI integration into supply chain management can drastically change things.
This is our feasibility analysis, and this includes technical feasibility, economic feasibility, and then there's a couple more on the next slide. For technical feasibility, it includes present technology and infrastructure, technical risks, and required expertise and personnel. Basically, it's talking about if we implement AI, advanced forecasting, and supply chain optimization, we have to upgrade things and make sure the technology is up to par. There are, of course, risks within AI and anything new to a company. And then it'll also need expertise to make sure that we have a good technical foundation. For economic feasibility, there's development costs and return on investment. Development costs include the hardware and software upgrades and collaboration fees with AI integration. And then for the ROI, there's demand forecasting, inventory optimization, and operational efficiency that should bring long-term savings. So it should help the company in the end. Continuing on with operational feasibility and legal and regulatory feasibility. For operational, there's problem solving and business alignment, readiness and user buy-in, and organizational changes. For problem solving and business alignment, the AI system will address our logistics core needs for accurate forecasting, inventory optimization, and enhanced efficiency. For readiness and user buy-in, management and department heads are aligned with this shift towards AI integration, but we need to make sure that the sufficient employee buy-in through targeted training and clear communication for the system. For the organizational changes, there will be minor shifts in workflow, um, and this is because the supply chain managers and data analysts will solely rely on AI's insights. For legal and regulatory, it includes compliance with regulations and cybersecurity concerns. For compliance, um, implementing AI, we have to maintain compliance with data privacy laws um, to ensure we are safeguarding customer data and adhering to the best practices for data protection. For cybersecurity, this team will work closely with the general counsel and cybersecurity experts to make sure that AI, this implementation of AI will protect our sensitive information against any and all cyber threats.
For our modeling and diagrams, forecast demand for inventory, we are looking over our ERD, or just more so each um, type of thing we need to go over. So for our first, we have our forecast demand for inventory. The primary actor, of course, is the supply chain manager. The goal is to generate demand forecasts to ensure that our, inventory levels are optimal. Um, a precondition of this is obviously that they need to have access to the AI system and data, historical data to track what past numbers were and so on. There are many success scenarios, such as the supply chain manager inputs the required parameters and submits the request. The AI system analyzes historical sales data, market trends, and inventory turnover. And we also have alternative scenarios, such as incomplete data. Let's say that, there is missing data. The system then displays a message that indicates, hey, the forecast aren't, as accurate as they should be or could be. Another one is an invalid parameter. Let's say if the supply chain manager enters an invalid or conflicting parameter, the system would also prompt them to revise that input. Moving on, we have optimized inventory restocking, primary actor, logistics coordinator, of course. They want to determine that the optimal restocking levels are where they need to be. So we are avoiding any overstocking or stockouts, which obviously are both very bad for the company. A precondition for this is going to make sure that the system is up to date with inventory levels and sales data, and that the logistics coordinator has the necessary access to do so. Um, scenarios, they access the inventory optimization function. They input the relevant details and submit the request. This then leads to the system providing restocking recommendations with suggested order quantities and timing. Alternative scenarios could be supplier unavailability. Let's say a supplier is unavailable, then hopefully, we could get alternative suppliers. There's also an overstock risk if high stock levels are detected, and then the system recommends adjusting restocking levels to avoid excess inventory. Lastly, we have monitor AI system performance, which would be done by the data analyst. The goal of this is to evaluate the accuracy of the data that AI is giving us, and this will help us improve future predictions. Precondition, make sure the data analyst obviously has access to the necessary data and forecasting outputs. Main success scenario, they select the option. They're prompted uh, for the time frame and product category to analyze, parameters inputted, analysis started, and in the end, the system will generate a report highlighting discrepancies and accuracy rates for each forecast. Alternative scenarios, maybe there's a data gap. If actual sales data is incomplete, the system will then alert the data analyst and exclude affected periods from the analysis. There could be a forecast model adjustment. So if the accuracy falls below a set threshold, the system prompts for a review of model parameters or provides suggestions for adjustments.
Slide talks about the entities and attributes that we will be using. So this diagram below outlines the main entities, their attributes, and the relationships between them for an order entry system. This includes customer, order, product, and inventory.
For this, we have three relationships. The first is a customer to order, a one to many, which is a single client can place multiple orders, but each order is associated with only the one client. Secondly, we have order to product via inventory, of course, which is many to many. Each order can contain multiple products, and each product can be a part of multiple orders managed through the inventory entity. Lastly, we have product to inventory, which is a one to many. Each product can be stored at multiple inventory locations, but each inventory record is associated with a single product.
The ERD's usefulness includes visualizing data relationships, identifying key data elements, and improved system design and efficiency and communication. So for visualizing data relationships, it describes the interaction of data entities such as orders, products, and suppliers and how they work with one another, which was on the last slide or two slides ago. Identifying key data elements, the ERD identifies what data is necessary for the system, ensuring completeness in data collection. Improved system design and efficiency allows our team to design a well-structured database, avoiding data redundancy and supporting efficient data retrieval. And then for communication, ERDs provide a visual model that can bridge communication between different teams.
Here's our functional decomposition diagram, which is of course going to help us break down these large complex processes into a array of smaller, simpler units. So first we have customer and supplier management. This is going to pertain to adding the customer and suppliers, the information, and then also managing the details. Then you have product and inventory management. This is going to add and update product information, track inventory levels and stock quantities, as well as set and monitor reorder points. Order processing is where you're going to create and modify orders. You're going to update the order status, process cancellations, and view detailed order summaries. Payment processing, accept and process payments, issue the refunds for the returned or canceled orders, and then maintain payment history for auditing. Demand forecasting and restocking, you're generating demand forecasts based on historical data, calculating restocking needs and placing orders, as well as analyzing forecast accuracy and adjusting parameters. Lastly, you have the reporting and performance analysis, which is going to involve the generation of sales and inventory reports, the production of forecast accuracy and performance reports, and the analysis of system performance for improvements.
Now I'm going to be going over our project plan. This slide includes project overview and key deliverables. So the objective of our plan is to enhance our logistics supply chain management capabilities through AI, enabling better demand forecasting, inventory optimization, and operational efficiencies. The scope of this project is to develop AI tools to support demand forecasting, inventory management, and restocking optimization with full integration across the company. Our key deliverables are AI-driven forecasting models that'll help predict inventory needs, inventory optimization that'll help with stock levels, and then training and documentation, which will provide comprehensive training programs and documentation for employees and efficiency. Continuing on, this is our phases for the project. Phase 1 is 2 to 3 months. Phase 2 is 5 to 6 months. Phase 3 is 3 to 4 months. Phase 4 is 2 to 3 months, and phase 5 is 3 to 4 months. Each phase includes important things we need to do to make sure this plan rolls out efficiently, including research and planning, development and integration, prototyping and testing, training and rollout, and then deployment and maintenance.
Project plan resources. First, we have our team members. This is obviously going to include a project manager, coordinator, our supply chain managers, development team, HR team, and our data analyst and scientists. For our tools, for project management, it's going to be Microsoft Project or Trello. Design is going to be done in Figma or Adobe XD. Development and testing will be done using Python or SQL or the combination of both. Collaboration, communication will be held on Slack and Microsoft Teams. And for data management and analysis, we have Power BI. However, could also use tool such as Tableau. For risk management, obviously there are many risks, delays in requirements gathering, technical challenges with the AI integration, resistance to adopting new technology among employees. And, that word resistance, it's not so much an intentional use of the word, but maybe to no fault of their own, they don't have a lot of experience with this AI technology. Mitigation strategies, regular meetings with stakeholders to ensure alignment on requirements, early stage prototyping to identify technical issues, comprehensive employee training programs to encourage adoption and ease transitions. The communication plan, we have weekly project team meetings to discuss progress and address issues. monthly updates to executive stakeholders, the use of shared project management tools for transparency and tracking. Success criteria is going to be, the successful implementation of AI-driven tools that improve the forecasting accuracy and reduce inventory-related costs. Positive feedback from supply chain and logistic teams on the ease of use and effectiveness, and project being completed on time within the allocated budget. This is our systems acquisition strategy, the alternative analysis table. We have the criterias, pre-built AI, custom-built AI, AI as a service. Based on our research, we have our implementation time. So for pre-built AI, it's going to be 6 to 8 months. Custom built is 12 to 18, and AI as a service, which is a much smaller thing, is 2 to 3. And just going down the line, obviously custom built AI is going to be the more expensive um, way to go over pre-built AI. And with that, it's going to be the longest, but you have benefits, right? It's fully customizable. What does this mean if it's fully customizable? That means its scalability is a lot higher. The security between custom built and pre-built is very similar. It is needed, you need a high level of security. We have talked about the potential risk um, between these. AI as a service, which is cheap, it'll be, it's quick. There are downsides. It's not, the customization isn't as good as custom built AI. But unlike custom built AI and like pre-built, it does have a strong vendor support. The security isn't as much a risk. And total co cost of ownership is low. User training is low, but obviously it is much different. Just back to custom built and pre-built real quick, we see that between the total cost of ownership and user training, um, they are both very similar. Ease of maintenance, that's going to be between the in-house maintenance or vendor provided updates. Um, and yeah,